All right, we're live. Hi, everyone. Welcome to our July community call. We're extremely excited, as usual, to share with you the latest news and updates about our product, OpenReplay, and to discuss some very interesting tech with our guest speakers today. But before we move on, in case you're hearing about OpenReplay for the first time, just know that it's an open source session replay platform that is meant for developers. If you want to know more, you can check it out at openreplay.com. So without further ado, let's get started with today's agenda. Like we usually do, we'll start with a general overview of the latest product updates news about the company by our CEO, Mehdi. We'll then move on to show you how we do data-driven design at OpenReplay with Sudhir, who's our product designer. And then we'll finally jump into Luis' computer, who's going to show us how to build microfrontends using web components. So, Mehdi, take it away.
Hey, thanks, Fernando. I'm not sure if it's only happening for me, for everyone, but I'm not seeing the deck.
That is my fault. There you go.
That's much better. All right, thanks for that. All right, good morning, good evening, everyone. Very excited to be here as usual and present the product update. So let's get the ball rolling. Okay, so we are working on the 1.7.0, which should come out tonight. It was expected to be released yesterday, but it wasn't yet fully ready. And we spent the last few weeks basically trying to answer and work on two main topics. The first one is getting rid of different bottlenecks that we've seen in previous versions on the back end, and then two, alleviate all of the user experience frictions, whether they're happening in the documentation or in our front end. So getting rid of the bottlenecks translated into a refactored backend. And actually, this is the biggest refactoring we've done to date, where we reviewed all of the ingestion pipelines and created a new service called Heuristics for analyzing sessions. The goal here behind Heuristics is to be able to extend it. So we will be releasing some documents, some documentation, and some READMEs about how you could extend that and build stuff around it. But I would say the main thing was the refactoring of all our microservices. Getting rid or alleviating all of the UI frictions, that translates into a complete and full redesign of the session replay page. So you're going to see a new replayer, a smoother mouse in all the recordings. And most importantly, we have enhanced what we call and what we track internally, the time to replay. So the time to replay is basically the time elapsed between when you click on the play button and when you see the recording popping up, right? And this is something we deeply care about. And that usually would take a bit more time, especially if you're dealing with large recordings, right? Recordings of few megabytes of data or recordings a few hours coming from users. So the way we have fixed that is by splitting large recordings into chunks and then being able to dynamically download them. So you'll see a big enhancement of that front. On the analytics level, we kind of redesigned errors and funnels. So they used to be separate sections in our front end. Now we brought them into the dashboard section, so they became as new metrics. So we have something called table of errors, table of funnels, and table of sessions. And this way, if you think about them as widgets, they could be very easily added to any dashboard that you're going to be sharing with the team. So that was the new thing that we've got in analytics. We haven't forgotten about assists, and actually we have introduced autocomplete. So now you can find sessions pretty easily. That helps a lot for those who have thousands or hundreds of concurrent sessions, concurrent live sessions, and they want to find the one that they care about. So now you can search by almost anything within the session. It could be the user ID. It could be any of the metadata you have attached to the session, and that's now easily done in Assist. And it follows the same logic as in the session list for replays. And then finally, Tracker. So Tracker, now we're sanitizing containers, or we're giving the ability through our sanitizer to get rid of containers and to completely sanitize them with the children tree. And we're better handling infinite lists, which used to be a bit tricky from a performance perspective. All right, now what's coming next? We're working on V1.8, which should be released by end of July. First of all, we're continuing all the efforts on the backend. So we're going to be finishing refactoring all microservices, even though the biggest part has been or is going to be released with 1.7. And then two, we're going to continue on that front for the session replay. So we're going to be using a virtual DOM for even a smoother replays when it comes to large recording. So think about 2 hours recordings, few megabytes, and especially like heavy grids or infinite lists. How can we make the replayer even smoother? For assist, we'll be introducing multiple live screens or support for multi-screen. So basically, if you want to follow 4 different users at the same time and being able to see those live sessions all at once, that's going to be possible. And also, we're going to be supporting the multi-agent call. Right now, if an agent joins a live session, a co-browsing session, and there is a call ongoing, the agent wouldn't be able to hop on the call or hear what's going on. So now we're going to be adding that possibility of inviting multiple agents to the same call. So those 2 things will be available with the V1.8. Apart from that, we'll be continuing the efforts on the redesign on the UI UX, getting rid of all the frictions as I was explaining at the beginning. So we'll be reviewing the session list page and preferences as well. And we'll be moving our frontend to React 18. Cool. As you may have noticed on our website or in the different tech blogs or press releases, I'm very happy to announce that we raised $4.7 million in seed funding. And that was led by Runa Capital, which is a firm that have invested in some very known OSS projects such as Nginx and MariaDB. Now, we're going to be investing all that money, or all that money will go into 3 different buckets: product, community, and content. So product, we are again on a mission to commoditize session replay. We're building this open source platform that developers can self-host for full control over their data. We're going to continue on our way of shipping features and building stuff around it. We'll be very soon releasing our public roadmap. 2, creating a community. So the way we see OpenReplay and our vision for the product is to have it as a platform. So all the developers and the community can contribute to it, extend it by building new plugins or integrations. And we're not yet fully there, but this is something we're working on. So this is where also we're going to be putting a lot of our efforts into. And then last but not least is making more efforts on the content. So by content, I mean our blog, where we're writing, we're publishing almost every day new posts about web development and JavaScript in general, and also a podcast that we started pretty recently. This is the best way to make OpenReplay known to the rest of the world. So we will be investing that money in all those 3 different areas. One last thing before I pass the mic to Sudhir is happy birthday to OpenReplay. A big thanks to the team and to the community for your love, support, and contributions. It's been a year since we first pushed our project to GitHub, and thank you all for the support and love we got so far. And without further ado, I'll be passing on the mic to Sudhir.
Hello. Good evening, good morning, everyone. This is Sudhir, product designer at OpenReplay. Today, I'll be talking about data-driven design. What is it? Why is it important? How is it practiced at OpenReplay? And then how can you implement data-driven design at your products? Okay, let's see what is data-driven design. I define it as a design process backed by data gathered through various research methods. When I say data, it could be any information that is gathered through quantitative or qualitative research. When it comes to quantitative, it could be the information captured through your analytical tools, A/B testing data. For example, Google Analytics capturing the visits, user location, the clicks, and the kind of devices users use. All of that is quantitative data. And then the qualitative data is the information that you directly get from the users. It could be through user interviews or users directly reaching out to the product teams through like various communication channels, or it could be through survey or any or in contextual inquiry or user interviews, etc. Great. So now we know what is data-driven design and what data is. Let's see why we should care about data-driven design. I think it is important and required because such design approach helps product teams understand who the users are in the best possible way or in a better way, and what their needs are and what the kind of challenges that they face, etc. And then also helps product teams move beyond some of the best practices that they follow, and then ultimately drive innovation within the product. At OpenReplay, we follow various kinds of research methods, and we use all of that to gather data and inform our design decisions. Out of that, obviously, like getting input from the user is the primary most one. So we reach out to our users, conduct user interviews with them, try to understand how they are using the product, and also like we get a lot of feedback from our community on Slack and Discord, GitHub, and then some of our users directly reach out to our CRM tools and share their feedback, questions, comments, etc. And obviously, OpenReplay being a session replay tool, we leverage our session replay capability to observe how users are using our product, to see if they are facing challenges, if they are hitting roadblocks, etc., and use all of that data to inform our design iterations. And then lastly, we use product analytics and also our inbuilt performance monitoring capabilities to see at a high level if there are any technical issues that users are facing. It could be like performance related or like resource loading issues like that. Okay, so next I'll give you a quick walkthrough of like a couple of examples to help you understand how we are using session replay and identifying opportunities within our product experiences. The first one would be about our website. We recently redesigned our website, and some of the pages are available for users to access now. And we observed through our session replay that the pricing page, uh, some of the visitors are facing issues. They are trying to click the list items within our pricing plans and trying to learn more information about those. So the snippet that you are seeing on the screen is from one of the session replays users are trying to interact. I think we have an opportunity to educate users even at this stage, maybe directing them to new page or like helping them with more information through tooltips, etc. So this is a learning for us. Now let's look at another example. This is within our product. So here, like you could see, I'm pointing at like more info. This is some information that users wanted to see upfront. Right now it is stuffed within a button. It appears upon click of a button, but our users wanted to see it upfront somewhere. So you can see it in the next slide, where one of our user was trying to find that information in different areas of the application. So like they try to identify that more information in multiple places, and this was a learning opportunity for us. We use this information to inform our redesign, which you'll see in the next slide. Here we are bringing up user information upfront to the top left. That is where user starts scanning their information from, and now it's very clear and obvious to them that this particular session belongs to this user who is browsing on Chrome, Android, and from France. Yeah, cool. So now let's see uh, how you could implement data-driven design within your product. For that, first you need to identify what your approach is. So I'm using this illustration from a book called Designing with Data. Here the authors have defined three kinds of data design philosophies. Those are data aware, data informed, and data driven. So the outermost one is data aware. Here, the product teams are just aware of the data and they don't do anything much about it, which means they are far from like what users wanted, and they may like cater poor product experience. And then is data informed design, where the product teams gather qualitative information from the users and then apply their instinct, knowledge, and experience to craft the product experience. And the last one is a data-driven approach, where the decisions are entirely made on the data that has been captured from various channels. I think at OpenReplay, being a small startup, we are at data-informed. We are adopting, or like we are practicing data-informed design philosophy. And as we grow, we want to move in the direction of a data-driven approach. Uh, Yeah, so once you have decided on your approach, you could see how you could implement within your product. So first, you need to identify uh, like what is your focus area. Fernando, if you can go to the next slide. Uh, yeah, so you need to identify your focus area, like what is the problem that you need to address within your product. Let's say you have an e-commerce website, and then you want to improve your checkout experience and maybe you want to drive more conversion. For that, you need to understand what are the problems users are facing or how you could enhance their experience. For that, you need to gather data, talk to users, gather some qualitative data, understand what their pain points are. And also you can use observation as a technique. So you could use tools like OpenReplay, you use session replays, see what your users are doing, see where they are hitting the roadblocks, and why there is a drop in conversion. And also you could use quantitative data like A/B testing tools and performance monitoring to understand the technical challenges. OpenReplay has dashboards and reporting capability to understand those technical challenges, and surveys are lastly another form of quantitative data gathering tools. So we are using these methods and obviously like more other data. So these are few things worth noting. Once you gather this data, you could inform it to inform your design decisions. Iterate your designs based on the data, the analysis that you do with the data that you capture, and then like build your screens and test them with users and launch it to your users. That's all I've got to share for today. With this, I'll stop over and hand it over to Fernando. Thank you.
All right. Thank you, Sudhir. That was very interesting. Now we're going to be moving into Luis' computer, and he's going to be talking about web components, which is actually a web standard that's been around for quite a while, but it's starting to catch up right now. And it's a very interesting piece of technology. So let me just switch the streams now. There you go. Luis, whenever you want, take it away.
Yep. Let me know if you can see my screen and hear me okay?
Yeah, everything's
Perfect.
great.
So hey guys, so my name is Luis Atencio. I'm an engineer at Citrix. I'm also a published author, so if you're ever wanting something to put you to sleep, just look me up. It will be mostly JavaScript, so if that's your passion, then we share that, and thanks in advance. And if you have any feedback on them, please let me know. But hopefully you enjoy them. So today we're going to talk about, kind of Fernando alluded to this kind of emerging technology, and we'll be throwing some nomenclature here and there. But first and foremost, I want this to be more dynamic, right? So Mehdi, Fernando, Sudhir, if you have any, feel free to interrupt at any time. This is supposed to be so just kind of like talking points more so than an official like presentation style, right? So this is just to sort of guide us towards the topic. So feel free to interrupt and make it more engaging. So let's talk about there's first of all, there's a ton of nomenclature here, right? What the heck is a web component? What the heck is a micro front end? And where does all this come from, right? I mean, we could intuit that a lot of it has to do with microservices, but this is for the front end, not the back end. So there's definitely a lot of stuff to talk about here. So let's start with some of the whats, right? So what is a composable UI? We're gonna be talking about that, because when you go micro, right, the idea is that you're not building a so sort of the current state of affairs, which is building the SPA, right, the single page app model, which is you deliver the entire experience to your users as sort of one binary, right? And then you use Ajax and things like that, lazy loading and all these other techniques to make it and chunking the lazy loading of the experience to make it sort of more seamless, and not that they're just kind of waiting for an entire chunk of JavaScript code to download at the beginning, right? When we transition over to micro front ends, then we start to talk about composability. And so composable UI is a UI that it's basically assembled from loosely coupled components. And the term loosely coupled is very important here, because when we talk about micro front ends, that's what we want to aim for, is loose coupling. Very similar to the philosophy of microservices, right? You want loosely coupled backends that talk maybe through an interface, or through a RESTful interface, or through a gRPC interface, whatever the mechanism is. It needs to stay loosely coupled with very strong contracts in the middle, right? And then we get this idea of the web components, which is, well, if we want to take this paradigm and push it to the browser, we need additional support, right? And that's what the web components APIs are. So this is it's been around for a while, but only browsers are, now the major browsers all have adopted them. And so I consider it to be still emerging, in the sense that we still haven't, gone beyond sort of the SPA single binary model into web components. And it's also not for everybody, right? It's kind of a niche API that you use it in certain situations. So we'll talk about that. But in essence, web components is a suite of technologies that these are browser APIs that you can use to sort of kind of emulate the experience that you have for microservices, in the sense that these things are siloed, they're isolated. Now, when you compose them all in the browser and everything is mashed together, how do you keep that isolation, right? But at the core, micro front ends, they sort of imply a set of technologies, but they also imply that it's about your team structure, right? And you have to set up a team. If you're Mehdi, if you're CEO of a company, or any other company, right? You have to set up your teams to sort of benefit from this. And the idea is that you empower the team. You empower the team to sort of work more in parallel, independently. Typically, micro front ends would be these front end apps that have their own CI/CD pipelines, their own requirements. Maybe they have even their own project manager, right? Maybe they're co-located around the world, in Madrid, in India, Miami, whatever the case may be, right? The idea is that these teams are working independently, and they're releasing frequently without having to sort of tightly depend on any other team, right? And keep in mind that we're building a single experience, yet keep everything decoupled, right? But it's all about the team. The example I'm going to show it's a very typical, kind of like very enterprisey website. The website doesn't really matter, right? You can take Amazon and slice it and dice it, to analyze how we can decompose a web UI. But think about this web UI that, you have kind of like your typical left-hand navigation, your typical right-hand content, and some kind of masthead or some kind of like navigation bar at the top, right? It's very, very common. And you say, well, I can kind of slice this into different apps. And the way you slice this is very, depends a lot on what you want to go for, how your team is structured, right? Because you could think, well, the navigation bar, maybe this is handled by the authentication team, because it's got a lot of like user management here. The left-hand side could be managed by, if this is like data-driven or this is dynamic, it could be handled by a different team. And then this can be also a micro front end on the right, right? So you could be looking here at 3 different apps coming together to build one, right? And there's typical, there's different ways of slicing. You can slice based on team preference or team sort of domain knowledge. You can slice on domain-driven design, right? You can take the domain-driven design approach and say, well, everything related to applications here needs to go together. Everything related to sort of navigation can go together. Everything related to like masthead or marketing and user authentication, things like that can go together. Or even you can go smaller and say, well, this can be a micro front end, but the right hand side here, the profile menu here could be even a different micro front end. So it really depends on how you wanna decouple these things, right? When you start to separate these out in whatever form you think is better, and the form that you allows you to go quicker, right? Well, then now you start to think about these things in sort of in isolation, and this is the whole point of this, right? So this team that is picking up the slice of the application, for example, will only ever be dealing with this boundary, right? And that's actually the beauty of it, is it reduces the cognitive load of everything else. So when I'm developing this app, I'm developing this app without regard for how this is going to work and how this is going to work, right? What you can do is establish some loose couple of contracts in between, and that's how you communicate, right? But from the point of view of development, I can sort of laser focus into my application, right? And I spoke about teams earlier, right? So you could have completely different teams, or it could be the same team working on it, but they'll each one of these little apps will have its own CI/CD process, its own set of developers, and maybe even QA, or maybe even site reliability engineers or site quality engineers, whatever you want to, however your company is structured. Even the APIs can be stored, the data can come from APIs that are stored in different places, right? Again, there's no limitation here. The only limitation is that when they come together, it needs to look like a seamless experience. It doesn't look like a disconnected experience, but in the back end, it's all disconnected. To the user, that doesn't seem to be, right? And that's the whole goal. If you're delivering an application to the user and it looks disconnected, then you've basically failed, right? Then the technology got in the way, and the paradigm wasn't the right thing, right? So the idea is that it all looks sort of assembled into one application, right? I'll pause here for now for any questions. If anybody has any questions or comments.
No questions yet, but if there are, we'll just address them at the end. Don't worry about that.
Okay, excellent. So so how big are these teams? Is there a rule? How should I decompose? So let's see if anybody can guess who said this phrase. If it takes more than 2 pizzas to feed a team, the team is too big. Anybody want to take a guess at that? Of who this quote belongs to? So this is actually Jeff Bezos, right? So we all know, definitely somebody very influential, right, in the web community. So the former CEO of Amazon, right? And the funny thing is that Amazon UI, which you can think of, it's a shopping cart, but it's got so many different apps from the grocery side to the shipping side to the payments to the catalog, and all of these are built as micro front ends, right? So it could be sensible that at a point in time, you could see one button be square, and then another part of the UI have the button be rounded because it's moving to the square, because these things evolve independently. But to power something like the Amazon dashboard, right? That's not one team, and that's definitely not one binary that's doing it, right? It's definitely thousands of engineers with building thousands of small pieces of the puzzle, right? And so when you have all these pieces together, so in microservices, we talk about, well, we can build REST interfaces between the back end. So what is the translation of that to the front end? Well, you can use events, right? Events is one way to do it. You can use the browser's local storage to store data from, one MFE can store data there. Another micro front end can pick up the data from there, right, and communicate via local storage. But typically, the easiest thing that, from my experience, has been just using events, right? The browser has APIs for dispatching and consuming and adding listeners for events, right? It's kind of like the bread and butter of the browser. And so that, that's very simple, right? Let's say in this example, you come in and you use the add app builder to create an app. The app gets published into the listing page and it gets sent via an event, right? And so these things are communicating. It's just loosely coupled in the sense that you can test these things independently, but when they come together, they function as if it were one app, right? So that's kind of the gist of the micro front end, right? Again, we were building composable UIs that come together. They're they come from different teams, are built with completely different CI/CD cadence, right? CI/CD processes, different release life cycles, different everything. But when they come together, they look seamless as one experience, right? So where does web components come in? So web components is technology that will enable the micro frontends to paradigm to come to life, right? The web components, we can talk about three different technologies: custom elements, the shadow DOM, which we'll go in a bit, and the HTML templates. I'll focus on, for today, since we're I know we don't have a lot of time. I'll focus on custom elements and the shadow DOM, right? These are the most two, for me, in my opinion, at least, the two most important ones. So what is a custom element? A custom element is the idea that your application can become its own, you can think about this as its own HTML tag, right? So when we deploy that app listing page that you saw there, so you can think of this as creating sort of kind of its own HTML element in itself. And this allows you to target styling and the CSS to make sure that the CSS is targeted at that specific element to be the parent container of your entire UI, right? Now, the UI is still being shared by the entire DOM in the sense that this is just another element. You can consider this to be a div of some sort, right? But it's got a custom name, and so that's essentially what it is. This doesn't provide a lot of isolation, but it does provide sort of containerization in the sense that you can target CSS to this particular sort of section of the UI, right? But then we step it up a little bit, because what could happen is that you could have CSS coming from different teams all loaded at once. You don't really know, because remember, when you're working in a micro front end, you're working in isolation, just laser focused on your UI. What happens if there's some other UI with, remember, CSS is global, right? So you could technically, easily override another micro front end CSS, and then the whole thing just kind of breaks. In the microservices pattern, it's almost like contaminating one server with another, right? We don't want that, definitely. We want these things to be isolated. And so we step it up, and we use a custom element API, and also we use this API called attach shadow that the DOM, the browsers provide. And when you attach a shadow to an element, this is a level of isolation, almost similar to what an iframe is. So you can consider this to be almost like a lightweight iframe, in the sense that you get full isolation of the DOM. It's all sort of stitched together in the same DOM as the other one, but this is using a completely different DOM tree, right? And now in this sense, the CSS that is part of the global application will not interfere with the CSS that's shipped, that's bundled within this CSS or within this shadow root component, right? So in other words, this is our boundary generator. This is what creates that yellow box in between, right? This is what lets us develop one micro front end independent from another, put them together in the same browser, and this, it just should all work, right? Because we won't have this cross contamination of styling and things like that. And sort of behind the scenes, this is kind of what happens is you have the light DOM, which is your typical HTML element, and this is your, the main DOM, if you will. And then to the main DOM, to the body of the element, you create this sandbox using the attach shadow API, right? You can create a custom element. You create a custom element in which you create a shadow root, just like we did in the example here, right? You create a custom element with a shadow root. And then to that, this is basically your application at this point, right? You can start a div, and underneath that div, you can add all of your, lists, tables, events, anything that you want, anything you can think of goes in there, right? A shadow component can also host another shadow component, and so you have embedded shadow components, right? Suppose, if we go back to this simple example here, each one of these rows can be its own micro front end, right? If you want to take it that far, right? Really, it depends on how you want to decompose things. There could be a lot of complexity in how these rows work, right? Because maybe they have click on actions, they have events, they can drag and drop or whatever. So it really, so now we would have a micro front end inside of another one, right? Again, it really depends on how you want to decompose your functionality and the team structure, right? But you could nest shadow DOMs this way. Now, what happens to all the CSS styling? So the wonder about this is that once you create this container, right, any global styles will not affect what goes inside. On the flip side, then that also means that you cannot sort of leverage global CSS. You have to bundle the CSS with your component. And this can be good and bad. So typically when we use something like React, we can use CSS in JS kind of pattern, and then the CSS is kind of bundled with the app, and you build it, you use Webpack or you use whatever you want to use. You build it, you build the CSS into the app, and then it all becomes one bundle, right? That's pretty easy. Things start to get a little bit more difficult when, let's say that your company has a global style guide, right? That you need to follow. And that is supposed to be used globally. Well, if you host it here in the Light DOM globally, you won't be able to use it within your shadow component. So you'll have to bundle it in, right? And if this gets too big, then your bundles can get too big. Another option is you can always have your shadow root reach out for your style guide, right? And that's another option that saves a lot of space. Again, there's that trade-off of, you bundle everything together to get easier portability of your micro front end. You can take it anywhere in any other app and use it. Or you can rely on global data and then global styles and and then that makes the bundle size smaller, but it makes your app less portable, right? So that's always a trade-off, right? Like I said, it's all about these benefits and drawbacks, and then it depends on how you what you want to use and what your priorities are. So for me, it was very important that we have the micro front end encapsulation, because we wanted to allow. So we had teams in Bangalore, we had teams in Europe, and teams in US. We wanted them to all be able to work independently of each other. So I was willing to sacrifice, increasing the bundle size of my micro apps for the sake of maintainability, right? And that's definitely a decision that we made, and it's worked out really well. And obviously we can start to optimize, as we get better at this, right? But right now, maintainability was the first goal. And so MFE encapsulation allowed us to have maintainability and sort of made things a little bit more reliable, so that we didn't have any unexpected global styles conflicting with our applications, right? We used events to communicate from one micro front end to the other. And this is something that the browser is sort of very well equipped to do, right? And so that worked really well. And because Shadow DOM is now supported by all modern browsers, then, with IE 11 and all that sort of fading away, there's no issues here with, browser compatibility. But just like with everything that's good, we always have some cons, right? Otherwise, this wouldn't be computer science, right? So it does add complexity when managing styles, right? You have to sort of be aware that there's this, that styles cannot influence your micro front end, and so you have to make that aware, right? People have to be trained to that mindset. There's some little small complications. I know the font face rule is not supported yet. These are some of the open issues that are, again, this is kind of emerging, and so some of these things are being taken care of, but there's always some lingering little issues that you have to sort of code your way around. Shadow root needs to be open to allow tag management. So this is like Google Analytics, for example. Google Analytics or things like Pendo. These are marketing tools that tend to work at a global level, right? Those need to be able to support, the Shadow APIs, right? So that you can plug them into the different micro front ends and not have this be loaded globally. And so if you have this option to keep your Shadow roots open, which allow global tools like analytics and things like that to peek into. It's called Shadow DOM piercing, to pierce into the div or the HTML structure of your Shadow DOM, right? So you do have the option to do that. A closed Shadow DOM will be full isolation. Nobody can get in. And open would be CSS isolation, but you have programmatic access into it, right? So that's another decision to make. Now let's talk about how we can use web components with micro front ends, and there's many different architectural patterns. But let's define micro front ends a little bit more formally, right? So it's like microservices, like I said, but for the browser, right? We want these apps to be isolated, but all sort of communicating and living together, right? So imagine that the browser is now like a Kubernetes cluster, right? It's hosting all these apps, and there's like sort of the networking between them, which is like your events, and the sort of the tunnels open between them, right? You can consider those to be the events. But micro frontends is also considered an architectural pattern for many, right? It's how it's because you have to lay out the data flow and how these events and how these apps communicate. To many other people, is a deployment pattern. They say, well, your apps are your apps, and how you deploy them is a micro front end, right? So it's really, I think, in my mind, is both, right? It does influence your architecture for sure because the data flow is impacted, but it also influences a lot in how you deploy it, because you have your CI/CD rules, and that definitely depending if you want to host your micro front ends with a CDN, or you want to host them with some kind of backend server, it does influence how you deploy these things, right? But all in all, it enables incremental upgrades. So if your site has 10 micro front ends, right, and you make changes to one, you should only be able to deploy one of them, right? So essentially, you're just upgrading 1/10 of your app at any time, right? Which means also there's 1/10 of the probability of bugs. There's 1/10 of the blast radio of any critical issues. So incremental upgrades are a real plus. So we've seen that when we do like major refactorings, we'll refactor one and just deploy one micro front end with the new code, let the other ones stay intact, right? And then we can incrementally upgrade the other micro front ends as they come in and as they get changed, right? And that allows us to mitigate risk quite a bit. They tend to be simpler and decoupled code bases, right? So we use a micro front end sort of in-house template, and every developer immediately knows where to go, right? It's instead of loading through like thousands of JavaScript files, you now go through potentially hundreds of them, and it just kind of diminishes the cognitive load quite a bit. Independent deployments, right? So once you have your CI/CD pipeline in place, you basically copy and paste it into each one of these micro front ends, and then the deployment becomes automatic. And then it's all about the teams, right? Like I said before, it's all about making teams autonomous. Let's see. So this is kind of like just enforcing that idea that teams are kept intact, right? And teams are kept sort of working on in their own silos, and they can have their own backend if they need to. They can share a backend with another server if they needed to. Again, it's just a matter of how you're structured and how you want to move independently, right? But you can move fast and move quick by allowing teams to be completely autonomous and minimizing the dependencies between them. If there's a team in Bangalore, the team in Bangalore doesn't have to wait for the team in the US to be online, right? They are self-sufficient, and they can release at any point in time, right? Micro front ends have different types of layouts or different types of architectures, and so you can host these things on the server side, and this is called server-side composition. I think React 18, you guys were mentioning moving to React 18, lends itself a lot to server-side rendering, right? So this is something that with React 18 you can definitely take advantage of, but with server-side composition, it takes it to a different level. So here it's you have the different micro front ends in place, right? You're building one client, right? Seamlessly from many different apps, right? Your apps are being assembled by some kind of web server that supports server-side include standard. And this is this is just markup that it gives you some markup to be able to stitch together these things, these apps on the server, and then deliver them as one HTML page to the client, right? So the stitching happens here, and it all gets delivered to the client as one HTML document, right? Another alternative to this is edge-side composition, which is you assemble these applications at something like a CDN, like Akamai. Like Akamai supports ESI, and again, it's just some markup that allows you to basically request micro front ends from different servers or different places, stitch them together into one page, and deliver that to the client, right? And so with edge-side composition, you get the benefits of caching that something like a CDN provider gives you, compression, caching. You get all these benefits, right? You have client-side composition. This is kind of the ones that's used the most, and there's some frameworks that enable this. So I would say that this is the JavaScript equivalent to the other ones. where basically you use kind of like a JavaScript framework to do the stitching on the client. And then the framework sort of pulls these micro front ends from either its own backend or a different CDN. So all these backends are coming in, all these micro front ends are coming in from different places, and they're being stitched together with this concept of like an app shell, or what we call also a base app, but using, just using JavaScript to do it on the client side, right? And then, so what about the data? So each micro front end, like I said before, could use its own data. They could share a backend. They could use local storage to get it. But how do we consolidate, or how do we make, if you have 10 different teams sort of contributing into one micro front end based application, how do we make sense of this data? So the typical approach is, well, every micro front end is independent, and so they would have its own API, right? So once you load the micro front end into the page, you can use REST to get access to its own backend, right? And so every micro front end will have its own API backend. And that kind of, it's a very simple model to follow. It keeps things separate, but the idea is that now you have sort of you're consuming entire APIs just to use maybe a subset of them, right? And a really good alternative that happens here is, well, we could also try to make some sense of this data ourselves. I mean, if we have 4 different backends, is there a way that a lot of these things can be related? You can have duplicate data in some of these backends, right? How do you deal with that, right? So an option to do this is something like GraphQL. And again, I'm throwing another term here, just kind of taking it a notch a bit. But using GraphQL, we could create like an API gateway, right? Where micro front ends use a GraphQL query, and then the backend is in charge of going through all the different API servers. And so in this model, your backends, you all use something like, if you're using React, then there's very simple Apollo providers, Apollo clients, to issue GraphQL queries to a central server. And then this is in charge of sort of federating across or stitching all these APIs together, right? So this becomes really powerful when you have a lot of micro front ends being stitched together, and then instead of having to whitelist and do cross origin requests to 10 different backends, what you do is you put these backends behind an API gateway, and then you use an easy query language like GraphQL, which is much easier than having to understand a RESTful interface to query for all this data. And now it also gives you the ability to make relationships amongst this data, right? You can say, well, I want some fields from this API, some fields from that API, mash them together and give them back, right? And so there's a ton of benefits that come from that, right? And that's kind of like an additional layer that it could be a route that you want to take, once you have the different micro front ends stitched together on the page. So let's talk about some of the drawbacks of micro front ends, right? So I've been talking about sort of all these wonders, and it's like, well, why is not everybody using this, right? Well, on the pro side, it is more scalable, right? You can, again, your teams are independently releasing, right, often or as often as they can, which leads to faster development. Deployment independence, so these things are loosely coupled, so there's no reason why we need to be dependent on any other app to be able to release, unless there's a major contract breaking refactoring, right? Which we try to keep those to a minimum. It leads to smaller, more manageable code bases. This is kind of the same as microservices, right? It's all the microservices pros get inherited from this as well. Easier testing. When your code bases are smaller, they're easier to test. And then you reduce the blast radius on every change, right? So if you're just deploying 1/10 of your app or 2/10 of your app, then that reduces the probability of bugs by quite a bit, right? In this case, 80%. There are some cons, and so this is actually from experience. We decided to make, so our site, our dashboard is composed of, we're at 8 micro front ends now. And so at any point in time, if we have to make a cross-cutting change to the way we do, let's say, authentication, or the way we do logging, I do find myself going into 8 different repos to make those changes, right? They're small changes, and they are small repos, but it can get very tedious to do that. But there are ways that we can mitigate that. So let me just go through the list first, and then we'll talk about each fix basically. So you have to manage a lot of repos if that's your strategy. Potentially code can be duplicated, right? If you have things like logging code or cross-cutting code, that could potentially be duplicated in your micro frontends, right? It can lead to using multiple view frameworks, right? Because if micro frontends are sort of technology independent, the only requirement is that they give you back HTML. How you get that HTML doesn't really matter. It can come from React, it can come from Angular, it can come from Vue, Svelte, whatever is your preference, or potentially even multiple at a time, right? One app uses, one team decides to use React, the other one decides to use Svelte. How do you do design guides? How do you do coding practices when you have like different view technologies there? It becomes difficult. And again, things like colliding with CSS, that becomes a major issue, right? If you don't use the browser APIs that we just discussed. So let's see how to fix these. So for the manageable repos, right? Well, monorepo is a solution. And these are tools like Larn or Turbo Repo. There's a ton of tools that allow you to do sort of monorepo style development, where you have like maybe a single package.json kind of drives the whole thing, and then changing one or deploying one deploys all of them, right? So this can definitely relieve the whole code duplication and also the ability to have to the annoyance to have to make sort of the same change across repositories, right? For code duplication, that's actually good. So microservices also suffer from this, right? If your microservices are typically part of like a single template, then you do find yourself, having to do the web framework configuration on every microservice, right? You have to set up cores, you have to set up your logging, your caching, and all that is duplicated code, right? You want to abstract that code as much as possible into some kind of common framework, and you can definitely do that here. But keeping things separate and duplicated to a certain extent is good. It can lead to using multiple view frameworks. Well, that's really only if you have to, right? I've seen it where teams want to standardize on a view framework, on a view technology. Like in our case, we standardize on React, but if we needed to, we could pull an Angular component in, and if that makes the deadlines, if that meets the deadlines, right, we could do that. So we have the option to only if we need to. But my recommendation is to come up with some kind of design guide and a standard, and that that the team agrees to, right? And then, as we know, well, we got web components to the rescue when we want to solve things like isolation and better so that one application is not contaminating another, right, in the same browser, in the same view. In the ecosystem, we have a few frameworks. I just listed maybe the top 5 that I think are mostly used. We use single SPA, which allows us to, which is a JavaScript only for client-side composition. Which allows us to stitch together React apps, Angular apps, and it supports a lot of view technologies. So it made things really easy. Pyrrole is also very popular, and then these other ones are also from the different companies. So the ecosystem is pretty big, considering that it's still kind of considered emerging. The ecosystem is pretty well built with a lot of options. It really depends on what you're trying to do. With single SPA in our case, right? We have this concept of an app shell, like I mentioned. With client-side composition, you use an app shell, which is really just a JavaScript application that just does the assembling of the UI in the client side. And so the single SPA gives you this very simple interface of a component can mount, unmount, and bootstrap, and that will translate to the different lifecycle methods. In the case of React, it would be like component did mount, component will unmount, etc. In the case of Angular, it would be its own lifecycle methods, right? They're all abstracted behind this very simple interface of mount, unmount, and bootstrap. And so long as you sort of override these APIs and call into your React code accordingly, then everything kind of just works magically, right? So that's one we've had a lot of success. And like I said, we use React on the client. So all of our micro frontends are React apps that we bootstrap using single SPA, and then we assemble them on the client side using the single SPA framework. And so we mix web components and micro frontends together. And so when we do that, this is kind of like a behind the scenes look of what you get. You get these micro frontends. Again, this is our left-hand navigation. These are the other two on the right-hand side. All of these are, each one of these is its own shadow root. And they can use their own backend, or they can use a single GraphQL interface to, talk to any API they choose, right? But typically, this is how it would look like. These are all their own DOM, all sharing or all sort of being hosted by one light DOM or one global DOM, right? But they're all completely isolated, and the way they communicate with each other is through dispatching events. And so the events become like our API contracts in this case. The event payload is our sort of JSON or our model, right? And that is, as a best practice, that is unbreakable, right? You can never change an event contract or an event model, right? You can only add to it, things like that. Just kind of like we treat it like as a RESTful interface model, right? And then finally, every single one of these boxes is its own team. These developers can be part of the other team, or maybe they're a completely different team, maybe a completely different country. But they will have their own CI/CD builds, and this release is independent of this release, independent of that release. But to the user, it's all one seamless experience, right? Like I said at the very beginning, if it looks desperate and decoupled, then we failed at implementing the paradigm, right? Now the technology is getting in the way of the user experience, and we can't have that, right? It's all about the user experience. So that's really it. And let me show an example here. This is the application loaded in the browser. And I'm just going to inspect this to show you behind the scenes how all this looks. Just looking at it from the sort of as a customer, right? Things look just like a single application, but on the back end, if you inspect it, give me 1 second. This is now you can see here. Let me make this a little bit bigger. See that's easier to see. Now you can see the shadow roots here, and this component that I'm highlighting here. You can see that section there. That's its own shadow root component, and it communicates with the navigation via events. And so you can see the isolation here. This application, in other words, this right-hand side component is built by a completely different team than the navigation is, right? And so that's how we keep everything isolated. But again, from the user experience, everything is sort of one experience, right? So that's really it, Fernando. If you guys wanna sort of parse this out, we can do some questions. And
Yeah, no, absolutely. That was actually very detailed and interesting. Thank you, Luis. We actually had a comment by a YouTube user Ariadne, who actually, by the way, had the answer to your quote question. It's just that given the delay that's between the live and the chat, we weren't able to show it on time. But
awesome.
so Ariadne actually asked a few questions that you covered during your talk about web components, but how to stick a web component inside another web component. You mentioned that they actually natively support that. And also Ariadne wanted you to cover Shadow DOM, which you did, so that's great. And finally, the last comment was about the global CSS breaking into the Shadow DOM CSS. And Ariadne said that they're working with Vanilla.js, Vanilla.js, CSS, and HTML. And using CSS variables, they're able to pierce through the Shadow DOM.
So I mean, if your Shadow DOM is open, right, then you can have programmatic access into it, and then from the outside, you could obtain this div element, for example, right, and change its attributes, do whatever you want to do, right? We would typically try to do them as closed components if possible. Except, when you're at an enterprise, you typically have to load all these user metric tools like Google Analytics and things like that. And some of these are just adopting web component technology little by little. Some of these already support Shadow DOM technologies, but they have the requirement that they need to be open so that they can do whatever it is that they do, right? They attach themselves to certain elements that you want to measure or you want to count, and so for that they need to stay open. So what we do here in this case is we keep our Shadow DOM elements open, but we do have a very strict set of best practices that you're not supposed to use Shadow DOM APIs to be able to obtain it. And so we enforce those through pull request reviews and things like that. And so for our teams, we share a set of best practices. And then when we onboard a new team into our dashboard and they want to contribute their own micro front end to the entire experience, we say, look, these are the guidelines to follow, right? And it's all about communication and it's all about team structure, right? At the end of the day.
Very good. All right, and quickly, because we're already over time, but actually she meant declarative Shadow DOM. Do you know about that, or any comment that you would like to add about that?
Declarative Shadow DOM. To be honest, I haven't come across that term, so I'll definitely look it up. But no, I haven't heard it before.
All right. That's fair. Okay, so thank you, Luis, again. It was a super interesting conversation. And if you want to know more about web components, we actually have 2 episodes on our podcast, 20 Minute JavaScript, that cover exactly this topic. So awesome. If you're interested, check it out. All right, so let me now get back to our presentation and just say thank you, everyone who's been here as a speaker or as the audience. This was an interesting hour. If you want to know more about OpenReplay or any of the content that we produce, feel free to follow us both on Twitter or the blog, where we, like Mary mentioned at the beginning, where we publish technical articles every day, or our podcast 20 Minute JavaScript, where we publish an episode every week. And that's it. But before we go, we're also hiring for these positions. So if you're interested in them or know someone who does, reach out to us on our Slack channel and we'll take it from there. So until then, see you next month on the next monthly goal. Thank you,
awesome,
everyone.
Guys. Thank you very much.
Thank you.
Thank you.
Bye, everyone.
Bye.